All right, welcome to the explainer. So you've probably dabbled with Mongoose, you know the basics. But today, we're going to blow past the basics. We're building a full-featured blog, and we're going to get our hands dirty with the real stuff, the tricky problems you actually hit when you're building something for real.
Okay, so here's the game plan. We're going to start at ground zero with data modeling. Then we'll make our data smarter, learn how to ask it really complex questions, tune everything for speed, and then see how it all comes together. Let's dive in.
All right, first things first. We've got to talk about what is honestly the most important decision you'll make when you start a project, how you structure your data. If you get this foundation right, everything that follows is just so much easier.
So this is the big question, right? Your data is connected. A blog post has comments, it has an author, and MongoDB, well, it gives us two really powerful but totally different paths we can take to model these relationships.
Now, this whole embedding versus referencing thing can feel a little heady, but trust me, there's a super simple way to think about it. Embed what a document contains and reference what it's associated with. Think of it like this. A blog post contains its comments, right? They belong to that post and only that post, so you embed them. Easy. But the author, they're their own person. They're just associated with a post and probably lots of other posts, so you reference them.
Okay, so we've decided to reference the author. Great. But there's a catch. When you look at your post document, the author field is just an ID, a long string of random characters. That's not exactly helpful when you want to display their name on the blog, is it?
And that is where Mongoose's magical populate method swoops in to save the day. Seriously, it's like a little helper that sees that ID, runs over to the user's collection, grabs all the author's info, and stitches it right into your post data for you. It's all happening right there in your app code, and it's just so incredibly convenient.
All right, our data model is looking pretty solid, but now it's time to make it smarter. This is where we stop just storing data and start adding some of the really cool dynamic features to our blog.
Okay, first challenge. We want to show how many comments each post has. Seems simple, right? But if we just store a comment count number in the database, what happens when someone deletes a comment? We'd have to remember to go and update that number and, well, things can get out of sync really fast.
And the perfect solution for this is something called virtual fields. The trick is, they don't actually exist in the database. They're not a piece of stored data. Instead, they're calculated for you on the fly whenever you ask for them. So for our comment count, it just looks at the comments array and says, hey, what's the length of this? Bam, done. And that's the absolute genius of it. No stored field means no sync issues. The data is always right because you're calculating it from the source of truth every single time you need it.
Okay, next up on our cool features list, automatically creating a nice, clean, URL-friendly slug from the post's title. So our URLs look good and are great for SEO.
To pull this off, we're going to use Mongoose middleware, which you'll also hear called hooks. Basically, they let us hook into the lifecycle of a document. We can run our own custom code right before an operation like save or right after. And for generating a slug, a pre-save hook is absolutely perfect.
Okay, pay attention, because this is a pro tip that will absolutely save you hours of pulling your hair out. I promise. That pre-save hook, it only runs on the .save method. If you use something like find first and save, your hook will get completely ignored. It's one of the most common Mongoose bugs people run into, so you have to be really deliberate about using the right hook for the right operation.
All right, our blog is really shaping up. It's got some smarts to it. But what about more complex questions? What if we want to add a most popular post section? That's when things get really interesting.
Yeah, for something like that, a simple find query just isn't going to cut it. We need to bring out the big guns, MongoDB's aggregation pipeline. The factory assembly line analogy is perfect. Your documents go in one end and they pass through a series of stages. Each stage does one specific thing to transform the data.
And this is where you see just how incredibly powerful the aggregation pipeline is. Look at this. We're just chaining together these simple, logical steps to build a super sophisticated query. First, we $match to grab only the published posts. Then we $add fields to create that comment count on the fly. We sort them, $limit it to the top 5, and then, get this, we can even use $lookup to pull in the author's details. All this heavy lifting happens inside the database, which is way more efficient.
So, our blog is a hit. People love it. But success brings a new kind of problem. As the data piles up, things start to slow down. We need to talk about speed.
Just imagine for a second, our blog has exploded. We're talking 100,000 posts. 100,000? That's awesome, but it creates a massive challenge. How in the world do you find one specific post in that giant pile without making your user stare at a loading spinner forever?
Well, without an index, the database has only one option, a full collection scan. It has to look at every single document, one by one, until it finds what it's looking for. It's like reading a whole encyclopedia just to find one definition. At scale, it's catastrophically slow. But with an index, it's a total game changer. The database uses the special sorted data structure to jump straight to the documents it needs. It's like using the index in the back of that encyclopedia. It's not just fast, it's practically instant.
So the key is to be smart about it. You can't just index everything. You want to create indexes on the fields you're constantly filtering on or the fields you sort by a lot. Makes sense, right? But, and this is important, don't go crazy. Every index you add adds a tiny bit of overhead every time you write data to the database. It's a balancing act between fast reads and fast writes.
Okay, let's zoom out for a second. We've covered a lot. Let's see how all these advanced pieces click together to build something that's not just powerful, but also super efficient.
You see how this all connects? We started with a solid foundation, the right data model. Then we layered on intelligence, making our documents smarter with things like virtuals and middleware. And finally, we tuned it up for performance, using aggregations and indexes to handle the heavy lifting. Each layer builds on the last to create a really robust, scalable application.
So what's the big picture here? What should you really take away from all this? Look, these aren't just abstract academic ideas. These are practical, powerful tools for solving the real-world problems you face every day as a developer. Mastering these techniques is what separates a good Mongoose app from a great one.
Whew, we have covered a ton of ground today. But honestly, this is just scratching the surface of what's possible. So to really push your skills forward, I'm going to leave you with a little challenge. We figured out how to find the most commented on posts. But how would you use that same aggregation pipeline to find the most active authors? Think about the stages you'd need. How would you group the data? How would you count it and sort it? Give it some thought. Happy coding.